This video is going to walk us through how to write intercept form of quadratic functions from the graph. So when you have the quadratic function, you have that parabola shape, and intercept form, which this is new, we've not talked about intercept form before, but intercept form is written as y equals a times x minus p times x minus q. P and Q are going to be your x-intercepts. So if you think back to when we talked about the properties of quadratics, then your intercepts would be, your x-intercepts would be on the x-axis. So we have one over here at negative 1, 0, and one here at 4, 0. Each line is counting by half if you look at the scale on the x. So that's why I know that that one is at negative 1. So I've identified P and Q as negative 1 and 4. And it doesn't matter which one's P and which one's Q. So I'll say P is negative 1 and Q is 4. So I would want to now write into the formula what I already know. So y equals, I don't know a, x, P is going to be negative 1, so that's minus negative 1, and x minus 4 for q. Now I would not leave this minus negative 1. I would rewrite that as plus 1, and I will do that in just a second. Now the other thing that we don't have is a, and we cannot write this equation without a. That was something that kind of came up in the week where you had to write vertex form, is that a lot of you were just leaving a and plugging in x and y, and that's not going to work. You're going to have to actually solve for a for the final form. Now we do also have x and y in this formula, so we can kind of do the same thing we did with vertex form, is that we can pick any other ordered pair and use that for x and y. So on our graph here, there are 3 that are kind of plotted. The vertex itself is not clear. It's not on an intersection of 2 x's and y's, so I would not use that. I would use either the y-intercept over here or this point here. Since the y-intercept is normally very easy to identify even if it's not marked, then that's the one I will use. So if I'm looking at my y-axis, this is negative 10 to 0, so they're counting by 2's here. That would put this one at 0, negative 8. So in my equation that I have, I'm going to replace y with negative 8. I don't know a. And then I'm going to replace all x's with 0. So this would be 0 minus negative 1, or 0 plus 1 to simplify it, and 0 minus 4. Now these mean a times those values, and so I'm going to solve for a by simplifying my parentheses and figuring out what was multiplied to get a. So this would be negative 8 equals a times 1 times negative 4, or negative 8 equals negative 4a. And then to solve for a, I would divide. So a would equal 2, because negative 8 divided by negative 4 is 2. Now I can write the intercept form using a and then the 2 x-intercepts, p and q. So y equals, in place of a, I'm going to put 2, and then x plus 1, because I don't want to leave minus negative. It's just not simplified. And then x minus 4. And that would be intercept form. Okay, so here is another graph of a parabola. And this one is opening downwards. So that tells me that my a value is going to be negative when I get to it. I can already tell just because it's opening downward. So the first thing I want to do is identify my x-intercepts for my p and my q. So this x-intercept appears to be at negative 5, 0. And this one appears to be at negative 1, 0. Again, looking at scale, I'm going from 0 to negative 2. That means every other line is counting by 1, or they're counting by half on each line. So let's call p negative 5 and q negative 1. So y equals, by the way, this formula is something you're probably going to want to write down to have to reference when you get to your assignment. So y equals a times x minus p times x minus q. And then I will put in the values that I know. So x minus negative 5, x minus negative 1. And then I'll just go ahead and simplify those. So that will be x plus 5, x plus 1. We wouldn't want to leave minus negative. Now we have the same issue that we still need a. And so I'm going to look for any other point besides the intercepts. We don't want to reuse points, so that I can substitute those in for x and y. So I'm going to use my y-intercept again, which is very clearly at 0, negative 5. So for y, I'm going to put negative 5. Don't know a. For x, I'll put 0, so that's 0 plus 5, and 0 plus 1. It goes in for every x. And then I will simplify. So negative 5 equals a times 5 times 1, or negative 5 equals 5a. And then, to solve for a, I would divide by 5. So a equals negative 1, which matches the fact that I know it has to be negative since it's opening downwards. Now I can write my intercept form of this quadratic function. So y equals negative 1 times x plus 5, x plus 1. And it wouldn't have mattered if I had said x plus 1 times x plus 5. It doesn't matter which one comes first. I don't really have to show this 1, so it may just show up as negative, and then x plus 5, x plus 1. Okay, so let's try this last option here and see if we can get that intercept form. So I'm going to start by identifying my x and y intercepts. So this x-intercept appears to be at negative 7, 0, and this one appears to be at 2, 0. So that makes p and q negative 7 and 2. So y equals a times x minus p, x minus q. And then let's call this one p and this one q. So we would have y equals a times x minus negative 7, x minus 2. And then we'll simplify the minus negative 7. So y equals a times x plus 7, x minus 2. Now we would want to use any other points to find a. So here your vertex is actually not too bad. Well, it's still a decimal because these are counting by half, so we won't use it. We'll use the y-intercept again. And this y-intercept, if we're looking at y, it looks like it's counting by ones, so that would make that at negative, or 0, negative 7. So for y, I'm going to do negative 7 equals a times 0 plus 7 times 0 minus 2. And that would be negative 7 equals a times 7 times negative 2, or negative 7 equals negative 14a. If I divide by negative 14, then I would get positive 1/2 equals a. So my intercept form of the equation would be y equals 1/2, positive a value because it's opening upward, times x plus 7, x minus 2. And that would be our intercept form. Now I wanted to look at this one because it's a little different. If you went to try to find your x and y intercepts here, you could find a y-intercept, but you can't find x-intercepts. And if you don't have x-intercepts, then you can't write it in intercept form. So this one would have to be written in maybe vertex form and then converted to standard form, but it cannot be written in intercept form. So if it has no x-intercepts, if it doesn't cross the x-axis, it can't be written in this form.